Welcome guys to another video from Datasolve. Glad you are here. In today's video, we are going to be building a conceptualized data warehouse in SQL Server. Yes, you've heard me right. So the purposes of today's video is to just give a brief amount of theory, and then we're going to dive into the practicality of building a data warehouse only using SQL Server, no external toolkit. So with that said, hope you have a cup of coffee, cup of tea, or preferred beverage of choice as we dive into today's video. So this video is brought to you by datasolve.tech. I am the owner of datasolve.tech, and we are a online database consultancy. We also build data warehouses. We build web apps for paying clients. So that's just a bit of self-promotion out of the way. So let's jump into today's video. And I want to start this video with saying, you will fail. Yes, you will fail. And to be more specific, you have a 63.75% chance of failure. Now, where am I plucking these numbers from? Well, I'd like to direct your attention to, there are 4 studies around BI reporting and data warehousing. Number 1 study, Gartner, reports that around 60 to 80% of data warehouses projects fail to meet expectations or objectives. McKinsey studies have indicated that about 70% data-related projects fail. TDWI approximates that 50 to 60% of data warehousing projects face significant challenges or fail to deliver. And the MIT Sloan Management Review suggests that failure rates for data initiatives, including data warehouse projects, are around 50 to 70%. If we step back a little bit from these 4 studies, and the messages that these studies deliver is that data warehouse projects fail due to a lack of clear objectives and strategy, poor data quality, complex data integration, or inadequate skills and resources. These are the 4 main reasons why a data warehousing project will fail. So in my personal experience, I can't stress how important it is to have that level of communication with your client, with your stakeholder. It's about syncing and reassessing. It's about understanding the roadmap and signing off on the dotted line to indicate with your stakeholder where you are at in the entire process from end to end. The good news is, guys, if you keep watching today, can reduce that average failure rate of yourself implementing a data warehouse, or you could simply hire me to do that for you. Before we dive in, these are a few of the resources that I've used to construct today's presentation. So on the left, we have quite a comprehensive and technical guide, building a data warehouse from Vincent Reynardi. Obviously in the middle, I use ChatGPT just to clean up the code, make things a little bit more understandable and a little bit, fine-tuned, if you will. I wouldn't say it's the be-all and end-all. At times, ChatGPT did lead me down a stray path. It made things a little bit more complex than it needed to be, which is so important around developing a fundamental understanding of what you are trying to do. So in the case you do need to debug something, you still have that fundamental knowledge. You're not throwing your fundamental knowledge out. You're still having an understanding. And lastly, on the right, we have the Data Warehouse Toolkit, probably the Bible in this industry around dimensional modeling and, if you will, data warehousing, by none other than himself, Ralph Kimball and Margie Ross. I'm sure everybody is aware of that in the industry. So to begin, we need to work with someone. We need a business use case. And in this instance, we have one, and it's called Hutchinson & Co. Hutchinson & Co. are a retail, you'd say a small to medium retail provider. So they offer in-house retail items such as t-shirts, electronics, books. But not only that, they have an e-commerce. They've just expanded to an e-commerce platform. And now the reason they're looking for a data warehouse is they're wanting to consolidate their data sources into one central location. They often use a lot of spreadsheets, and they're a bit tired of doing so. They want to consolidate. So kind of stepping back a little bit from that, if we refer back to the Kimball Methodology, He mentions that we need to identify business processes before designing a data warehouse. So here we are. The first business process is order management. So what to do when the customer makes an order, how can we track stock levels, or how can we track the status of an order, where it is, etc., etc. Customer relationship management. How can we understand entities that interact with the business and what does that process look like from a data perspective? Inventory management. So once you order a product, how do we know what the stock level is? Is that kept on file? Where are we getting that information from? Lastly, we have sales and transactions. This is a big part of the business process. Obviously, trading, making upwards of 1,000 transactions per day. So today we're going to focus on one of those business processes, which is sales and transactions. The whole idea is to convert this business process, sales and transactions, into a dimensional model for people to query, for us to use in a dashboard, etc., etc. But we need to have an understanding of the entity relationships, hence this diagram. So here we have just a mock entity, a mock ERD, and we can see here, if you're not familiar with cardinality, I'm not going to go too in depth, but I've kept it very simple. Customer may have many transactions. One transaction may have many orders. I think that's pretty self-explanatory. I'm not going to go too in depth there. We're going to expand out because we also need to know about products, and we also need to know the store location, because some of the transactions are coming from online and some of the transactions are coming from in-store. So here is a more robust model. It is recommended that ERDs are in a normalized state, and in this case, it is a 3NF. Now you may be asking, what is 3NF? And that is just the level of normalization that this database model is in. So before we go too deep into this ERD model, it's always useful to understand what normalization is. In this normalized model, we are in 3NF. To understand 3NF, we need to understand 2NF. Thus, we need to understand 1NF. So to start, we need to understand what not is 1NF. And as you can see here, we have an example of what not is 1NF. So hopefully that makes sense of the wording. So as you can see here, we have the products column and we have two values in that. So it looks more like a user error, and most database systems will prevent this from happening. Most database systems are already by default in 2NF. Now, what is 2NF? So non-key attributes dependent on part of a composite primary key. So what is the composite primary key? So just another definition, a composite primary key is a set of columns. So I'd say 2 or more columns, which in its entirety will be unique. So it'll be a unique identifier. So okay, let's take for example, so non-key attributes, which would be the enrollment date. This depends on this composite primary key. So the composite primary key will be student ID, course ID, student name, course name. So this has a partial dependency on this composite key. In order to remove that partial dependency, we need to split into multiple tables, thus doing so. Not being in 3NF, we would say that we have what's called transitive dependencies. Non-key attributes dependent on other non-key attributes. Okay, so where are the non-key attributes? So let's say this is a non-key attribute. So this will depend on this non-key attribute to find out who the customer is. So much like the example for 2NF, we would need to remove this transitive dependency by creating additional tables. So the summary here is 1NF ensure atomic values and no repeating groups. 2NF is to eliminate partial dependencies, and 3NF is to eliminate transitive dependencies. That's more so of a quick summarization of what being in 3NF is. So moving forward through that, we're going to convert that normalized model into a denormalized model. We are using a star schema denoted by the natural shaping of the tables, and we can see here the fact sales in the middle connected by all the foreign keys of the surrounding tables. I've added one table here, which is the dim date, and just a quick definition: dimensions can be thought of, or dim tables can be thought of attributes attributed to their fact tables. A fact is basically a table which carries an additive measure. So what does that mean? It means, so in this case we have fact sales, but this fact sales has a quantity, has an amount, has a total amount, has all these additive fields which the dimension tables do not carry. And this is the structure. This is a well-accepted structure in the industry. What's the point of having the dimensional model and having the ERD? So the problem with using a normalized model is that it's not efficient for querying. We don't use that for the final tables that we're going to be querying. It's also common practice that the end user doesn't have access to the normalized data store. And one of the reasons we do that is for usability and to help the user understand the data. There actually was a study conducted which demonstrated that users had a better recall for relationships when using a dimensional model. Moving forward, this is the ETL design, and this is what we're going to go through now in SQL Server. I'll give a high-level overview. So we have two flat files, two CSV files acting as source, one for in-store transactions and one for e-commerce transactions. We then go through a stored procedure to load them into the raw source tables. Furthermore, goes into another set of stored procedures to load into the staging tables. And staging is, just a place in your database or data warehouse to manipulate the data. This is what they call ETL, extract, transform, load. Further after the staging, we go through a validation. So checking if the numbers are adding up, how many rows we're inserting, how many transactions are we inserting, is that correlating with the source data? Because the last thing you want to do is go through all these transformations, but you miss out one or two records. So your data set is wrong. And this will lead to further complications down the line. So you must validate your data somehow. We've then got the final load into the DIM model. That's effectively it. With that said, let's jump into the system and I'll give you a rundown of the code and what it looks like in SQL Server. So let's go. All right, guys. So before I jump into the SQL Server, I'm just going to show you, I have two plugins. So my system may look a little bit different. So I am using this SSMS schema folders, which is good for organization. And I am using this SQL shades to give me a dark mode. So I'll have the link in the description about that. So with that said, let's jump into the code here. So as mentioned in the ETL diagram, we do start with the source. So I guess that would be the best place to show you. So I have got and I used a Python script to generate my dummy data. So here it is here. So basically we're just generating 1,000 rows of data. We've got product names and a set price. One customer can have many transactions, and I'll show you what the transaction will look like. So this will generate e-commerce, and I have one which will generate the in-store, claiming the data source or the source data will look like. This is what will be ingested. So as you can see here, it's a one-to-many relationship. So it's a one-to-many relationship. So for example, Charles Foster, he's made three orders under the one transaction. So he's bought a Nike, let me just expand that. He's bought a Nike t-shirt, Dell XPS 13, and a Samsung refrigerator for these prices. Now, you might be wondering, can we have more than one customer for a transaction? The answer is no. One unique customer per transaction. And this John Smith 2, John Smith 3 is an error. And I have deliberately put that in there so our data warehouse will pick that up and it will put it in a review table. And this will come up in the wash later, but that's effectively the source data that we're playing with. I won't show you the in-store. It's basically the same, but with a store column. Cool. So hopefully that makes sense. Let's jump back in. So here are all my schemas in the stored procedure. So I want to open up the master. And this master run ETL processes what it will do is it will load all these stored procedures in order. Now, mind you, this is a conceptualized data warehouse, so it will only have one load. In that case, it's not realistic because in reality, you would have a merge statement. So it will insert if it doesn't exist, or if exists, it will update, upsert. Just to give you a quick overview. So number one, we are cleaning the data. So we are removing and truncating tables. Then we are loading our source. Then we are normalizing, then we are validating, and then we are loading our final data there. Pretty straightforward. So let's jump into the raw source. So what's happening in here? So we'll jump into install. So we're creating a temporary table. We're inserting the data into that temporary table and a simple select. Pretty straightforward. Then from there, we're going to normalize. Gets a bit trickier from here. So what we're doing is we're normalizing, we're inserting into all our staging tables. So as you can see here are all the staging tables. There are an extra few ETL log and duplicate. You can ignore that. And I've shown you the diagram so you get an idea of how it's structured. So insert into staging. So we're inserting into the store location. Please note a lot of these insert statements have this where not clause, and what it effectively means is we don't want to insert the same data twice, hence the need for this where not. Insert into customer, insert into products, using CTE to ensure unique transaction ID. So when we insert the data, we're not going to insert, as you can see here in the source, there are a lot of duplicates here. But when we insert into the staging tables, we're only going to insert one record. Hence, we need this unique transactions. We can see here, insert into transactions where it doesn't exist, insert into orders. Pretty straightforward. So I'm going to show you something. So in the e-commerce, I did need to provide some validation. This is where I handle the John Smith scenario, which I showed you here. So how do we clean that out? So we are using a temporary table and we're picking up transactions which has a distinct email greater than 1. So that would pick up 3, 4 unique emails. So that query will put 4 records in review. Now, you need to be very understanding when it comes to picking up dirty data, and there's a lot of different ways to slice and dice. I'm not going to go too much in depth in here, but you need to know what exactly constitutes dirty data, and are we removing all records, or are we removing one record? Or, there's a lot of thinking and planning involved about removing dirty data. So I've only put in one dirty record, and that'll come up in the wash. So what it will do is it'll insert into a review table. So this is the review table here, review transaction. Yep, so that'll insert there. Inner join, insert into staging customer. Obviously making sure it doesn't exist in that duplicate transaction, and it doesn't already exist in the table we're inserting into. Insert into products, and that's about it. Bit of validation, verification there. So that is the normalized part. So if we go back to once we've finished normalizing, then we are going to validate. All right, so what does that mean? So validate, we'll be going into this one, validate data. So all this is doing is, this is might be a bit redundant, this part, but we're loading in the records again, the source records, and here are a bunch of fields that we're using to measure whether or not our data is accurate. So this will come up in the wash later, but this is just used to verify that our totals match, our total transactions match, etc., etc. That, as I said, that'll come up in the wash later. Once we've validated that, then the final stored procedure, which is run, The final stored procedure which is run is this load final data, which in effect will just load the cleaned version and will just load into the final dimensional tables. And there is one final validation to make sure that the final data still balances to the source data. So what we'll do now is we will run this from start to finish. All right, so the beauty about this is all we need to do is run one stored procedure to run all 7. So we just hit OK, execute that. Now, what it's doing now is it is executing. What are the messages? Now, I've programmed it to send an email. So I've programmed this pipeline to send an email. And this is the email here, datasolve notifications. So we'll go through this. So it went through the clean, the load, the normalize, the validate, and the final load. Here are the validation checks. Very important, very integral part of building that data integrity piece within your data warehouse. So here it is, the data validation check. So it's counting total records in source, total records in review, and total records in staging. There is a formula to calculate whether it is valid. So it should basically be this value plus that value should equal this value. There it is, valid. 2728490. That is bang on the money. So that is correct. So for my part, that looks like it is passing the data validation check there. So in essence, this has been the pipeline. That's basically it. I've tried to provide as much documentation in my blog. So if you want to build this yourself, I've got all the scripts there. You can build it yourself. You can trial it yourself. I've got a more in-depth explanation in my blog where I talk about the database that I built, how that works. So I go into detail about that in the blog. That's effectively it, guys. Hope you enjoyed it. If you want to work with me, send me an email or contact me. Hope you enjoy your day, and thanks for watching.